Here we're demonstrating the virtual me telepresence robot. Telepresence robot is basically a robot with which you can go interact with people remotely. The robot has a tablet as a head, so you can interact with the people there, just like a Skype conversation. So over here, we have basically designed the system for use by an elderly person. So over here you can see the follower system that we developed. It's just a quick video. So basically the way this works, there's a Microsoft Kinect mounted on the top of the robot, and the Microsoft Kinect obtains depth images from the environment. And it takes these depth images and it searches for joints on the body. It searches for a head, arms, legs, and it takes the averages of all of these and it looks for the center of mass of the user. Once it has the center of the user, it can calculate a velocity command to send the robot to that destination. As you can see here, it always maintains a certain amount of personal space. So that constant, of course, is subtracted from the distance value before sending it to the robot. Now this follower is one of the few features which we implemented to make the robot easier for the elderly person. So I can demonstrate to you over here. We also designed an Android application. And this application is basically a voice command application. It uses a Google voice recognition service. So if you click on that, the Google service comes up and it prompts you for a command. Currently there are 3 commands on the system: follow me, stop following me, and return to dock. So the follow me command basically just launches the follower that you saw in the video. In addition to these systems, we have also improved on the existing system. Now you can visit us at our website. It's UOITvirtualme.wordpress.com. All the information about our project is here, including how the tracker works. And you can see here the center of mass of the user. That's what the Kinect actually sees. So over here is the other component, the mapping component. The mapping component basically generates a 3D map of the room. And inside this 3D map is information about all the obstacles. So you know the position of every obstacle in the room. Once you know the position of every obstacle in the room, this information can be fed to a path planner, and the path planner can use that to navigate the room autonomously. Now, if you scroll down a bit more, the final system that we implemented is basically an odometry system. So this odometry system, with the original system, the robot used to drift about 0.7 meters for every 3 meters traveled. Now, with the new visual odometry system, the robot only drifts 0.1 meters for every 3 meters traveled. So let me just quickly show you another 2 small features over here.
Sure.
Over here we have the inertial measurement unit, which is basically an accelerometer, a gyroscope, a magnetoscope, a barometer, and a temperature sensor. Of course, we're not using the temperature sensor here, but basically what this does is it measures the rotation. And if you take a look at the screen over there, you can see as I rotate the IMU, this thing rotates as well. And this was the sensor which we were planning on using to determine the position of the robot. Unfortunately, we realized that this sensor is only good for obtaining the absolute orientation. When you try to find lateral distance, you have to double integrate the acceleration, and this results in a summing of all the errors over time. So therefore, we moved to the visual odometry system. And the visual odometry system basically keeps track of all the features in the room, and it uses these features to determine the position of the robot. And the final thing I can show you here today is our emergency stop system. So it's basically an infrared transmitter and receiver. And when you bring your hand close to the transmitter, you can see over here that the LED comes on. So as I bring my hand close to the sensor, the LED comes on. Right?
Oh, wow.
So this is basically the emergency avoidance system. So the path planner should technically keep the robot away from colliding into any obstacles, but just in case the path planner is to fail, this thing will ensure that our product remains safe.
Wow. And I mean, I've seen a lot of demos you have shown me on video. So far, so great.
Yeah.
I mean, you're sharing so much information. So are you planning to keep this project open source, or is there some type of closeness to it as well?
Well, a lot of the software packages that we use to develop this are open source. I mean, we use open source IDEs such as processing and Arduino. So a lot of the project will be open. However, the robot itself belongs to the company called Crosswing, who presented us with the robot
the posters
framework.
right over there.
The posters over here. So here you can see the Crosswing logo. So they're the guys who provided us with the actual robot framework. So all rights are reserved to them. We are giving them all of the software. and they will decide how to use it in their future releases. I believe it is their plan to send this robot into many different fields, not only for elderly people, but perhaps in hospitals, as well as to greet customers in stores and several other avenues.
Thank you. I mean, I mean, this is one of the projects that I've seen as most involved. You have some electrical components, you have software, you have mechatronics, you have artificial intelligence. Great work, and congrats again.
Thank you very much
for your accomplishments.
Thanks.